Ever wondered why you feel lighter on the moon but still weigh down your bed on Earth? Let's bust the myth of mass versus weight in a way that'll stick with gravity. What is mass? It is the amount of matter in an object. Think of it like the stuff something is made of. For instance, the mass of a block is greater than the mass of a balloon because a block has more matter in it than a balloon. What is weight? It is the force of gravity acting on an object. The force of gravity pulls all objects toward the center of the Earth. As weight depends on gravitational strength, it changes with the change in gravity. It is larger with a strong force of gravity and smaller with a weak force of gravity. An object has a greater weight on Earth than on Mars or in space because the force of gravity is stronger on Earth than on the moon or in space. Here's a fun fact. The moon's gravity is only 1/6 of Earth's. So if you jump on the moon, you'd actually feel like a superhero, minus the cape. Cool, right? Then, what are the differences between mass and weight? The mass of an object does not change with a change in gravity, while the weight of an object changes with a change in gravity. The mass of an object can never be zero, while the weight of an object is zero with zero gravity. Mass is a scalar quantity. It only has magnitude, while weight is a vector quantity. It has both magnitude and direction. Mass is measured by a beam balance, while weight is measured by a spring balance. Mass is measured in kilograms, while weight is measured in newtons. However, mass and weight are related. In fact, the mass of an object is directly proportional to its weight. The larger the mass of an object, the larger its weight, and vice versa. The weight of an object is calculated by the formula W is equal to mg, where W is the weight of an object in newtons, m is the mass of an object in kilograms, and g is the gravitational force. Earth's gravitational force is 9.8 newtons per kilogram. Let's consider some examples. What is the weight of an 80 kg man on Earth, the moon, and in space? Let's start with Earth. We know that weight is equal to mass times gravitational force. The given mass is 80 kg. The Earth's gravitational force is 9.8 newtons per kg. 80 times 9.8 gives 784 newtons. Therefore, the weight of an 80 kg man on Earth is 784 newtons. Now on the moon. Weight is equal to mass times gravitational force. The given mass is 80 kg. The moon's gravitational force is 1.6 newtons per kg. 80 times 1.6 give 128 newtons. Therefore, the weight of an 80 kg man on the moon is 128 newtons. Then in space, weight is equal to mass times gravitational force. The given mass is 80 kg. The gravitational force in space is 0. 80 times 0 gives 0 newtons. Therefore, the weight of an 80 kg man in space is 0 newtons. Another example. An object on Earth weighs 20 newtons. What is its mass? The question is about the mass of an object, therefore, the formula is mass is equal to weight over gravitational force. The given weight is 20 newtons, and the gravitational force on Earth is 9.8. 20 over 9.8 gives 2 kg. Therefore, the mass of a 20 Newton object on Earth is 2 kg. Here's a quick challenge. If your weight on Earth is 392 newtons, what's your mass? Write your answer in the comments below. To recap, mass is the amount of matter in an object, and the mass of an object is the same regardless of the change in gravity. Weight is the force of gravity acting on an object, and the weight of an object changes with the change in gravitational strength. It increases with an increase in gravitational strength. The weight of an object is calculated by the formula weight is equal to mass times gravitational force. The next time someone says mass and weight are the same, blow their mind with physics of course politely. Now that you know the difference between mass and weight, in the next video we'll dive into how to measure the volume of substances. Stay curious, stay grounded, stay LearnStalk.